Hello guys, in this video we are going to see a sum where we have two inputs. So this is also a design sum of fuzzy controller having two inputs and one output. Let us see. So design a fuzzy controller to determine the wash time of domestic wash machine. Assume that the input is dirt and grease on clothes. Use 3 descriptors for input variable and 5 descriptors for output variable. Derive set of rules for control action and defuzzification. Clearly indicate that if the clothes are soiled to a larger degree, then the wash time will be more. So here what the question says is you have two inputs, that is dirt and grease. So dirt and grease are the two inputs. So what is this is basically a fuzzy design of a machine or washing machine used to wash the clothes. So input clothes, we input clothes in the machine. So that clothes contain dirt or grease as the impurity in them. So what input is basically to understand how much dirt is there in the clothes and how much grease is there. So these are the two inputs. And what is the output? How much time should the machine wash the clothes? That will be the time. So let us start. So step 1, you take the inputs and outputs. So input is dirt and grease. So here they have told us to put 3 descriptors for inputs. Use 3 descriptors for inputs. So there are small dirt, medium dirt, large dirt. This is again your choice. You can put any name that you want. So I have given small dirt, medium dirt, large dirt, and I am taking this in percentage. So this value will be in 0 to 100 percentage. Next, grease. Grease similarly, small grease, medium grease, large grease. Same thing in percentage. Next is output. So output is time. So time, they have told us to use 5 descriptors. Hence I am using very small, small, medium, large, very large. So this is the descriptors for time. Also the minute. So there are 60 minutes. Say 0 to 60 minutes is the range for time. Similarly, we will plot the functions as the membership functions over here. So here I will get 3 graphs now. Why 3 graphs? Because I have 2 inputs and 1 output. So I have named X, Y, Z for the 3 input outputs. And next thing is you have 3 descriptors for input. So I have taken 0, 50, 100. 0, 50, 100, and you take the triangular membership function. So here there is small dirt, medium dirt, and large dirt. Similarly, small grease, medium grease, and large grease. For time, you have 5 descriptors. So you have very small, you have medium, you have large, you have very large. So the next thing is you have to take the equations of all these lines. For the equations, please refer to my previous video on fuzzy controller. So you can get the equations by the 2-point form. I have described everything in detail in that video. Please look at that video. And the next thing is you get the equations. So after getting the equations, you form a table. So here are the set of equations and their corresponding range. Remember, range is very important in these kinds of sums. So there is dirt rules, grease rules, and output rules. So I have all these rules with me now. Next thing that we have to do is this thing is a little different in 2 input sums. That is, here you have to basically map. In the previous sum, in the previous video, if you had seen, there was only one input and one output, so you could directly map the input to the output. But here, since there are 2 inputs, you have to form a table. So what is the table? Let's see. So this is the small table. This is 3 by 3 because there is one input over here, one input over here. So small dirt, medium, large dirt. Similarly, small grease, medium grease, large grease. So because 3 input descriptors for both the inputs, hence this is 3 by 3 table. So next thing that you have to do is here you have to map these values to the time. So now this is totally on your logic, on how you think, on how you want the application to work. So here what I have written is if suppose there is small dirt, means there is very small percent of dirt in the clothes, and small grease. So what should be the time? So if there is small dirt and small grease, the time should be very small, because there is very small, so things will wash out in less amount of time. Hence here I have written very small. Similarly, say there is medium dirt and medium grease, then you will require say medium amount of time. If there is a large dirt and large grease, so now everything is large, so you will require very large amount of time, so hence VL. So what you have to do is basically map the time values to the corresponding input values over here. Now if you consider medium dirt and small grease, so there is medium dirt and there is small grease, so the grease is less but there is dirt is medium, so accordingly I can say that say small amount of time is sufficient. Similarly, small dirt and medium grease, small amount of time is sufficient. If there is large dirt, too much of dirt and small grease, so say medium time is, so these values are totally on you, you can choose anything, but then that should be logical. Now you cannot have small dirt and small grease very large time, so because that will get washed in less amount of time because there is small. So logically whatever comes to your mind, you can fill this table accordingly. So that was a new part that we learned in this video. Next is the same thing, you have to consider input. So that is you have almost done your sum over here, just you have to test your fuzzy logic. So here what you do is you consider dirt as 60%, this can be any number, you can take any number over here. Grease 70%, again your choice, any number. So this is 60%, 70%. Next what you do, you put these values in the input table. So here you see where does 60 comes. So I have taken dirt as 60, so for dirt I will consider these equations, so 60 comes over here. For these two equations I will get 60, so I put 60 over here, that is in place of x you put 60, so that is 100 minus 64 by 5. Then 100 minus that is 60 minus 50, so that is 1 by 5. So you get the two values over here, 4 by 5 and 1 by 5. Also note the corresponding medium dirt and large dirt. Here you can see medium dirt, large dirt. Next, for grease I have choose the value 70%, so go in the grease rules. So here you can see 70 comes over here, lies over here from 50 to 170. Put y is equal to 70 because this is y. So here you put 70, 100 minus 73 by 5, and this is 70 minus 50, so that is 2 by 5. So you get 3 by 5 and 2 by 5. So now you have got the individual inputs, but then this is AND case, means here you have considered 60% grease and 60% dirt and 70% grease. So what you need to do is next is you have to intersect all of them. So that is you consider medium dirt. Please write these distinctly, I'll tell you why in a minute. So here you write medium dirt and large dirt. Then there is medium grease and large grease. So 4 by 5, 1 by 5, 3 by 5, 2 by 5, the values that we got now. Next, intersect this with this. So medium dirt intersection with medium grease. So these two intersection. So we know in fuzzy logic intersection means minimum. So the minimum of these two is 3 by 5. Hence you write 3 by 5 over here. Next, intersect this with this. So medium dirt with large grease. So that is minimum of 4 by 5 and 2 by 5. So the answer is 2 by 5 and you write it over here. Next, large dirt, medium grease. So 1 by 5, 3 by 5. Minimum is 1 by 5, you get 1 by 5. Large dirt, large grease. 1 by 5, 2 by 5. Minimum is 1 by 5, you get 1 by 5 over here. So now these are the actual inputs that you have got. So this is the input. You have to choose the maximum value of these. So the maximum value of this is 3 by 5, as we did in the previous video also. We choose the maximum rule. Don't get confused, here we are choosing the minimum because we are taking the intersection of these two things. Intersection, that is AND. I want medium dirt and medium grease, or large dirt and medium grease, so that AND makes that intersection, and because of this intersection you take minimum. So I, for this value, say I took the minimum of medium dirt and medium grease, so 4 by 5 and 3 by 5, minimum is 3 by 5. After all this, now what you have to do is basically you want to take one value, you have to consider a value, so that is according to the defuzzification method. So here the simple defuzzification method is choose the maximum value. So the maximum value is 3 by 5. See, 3 by 5 corresponds to what? It corresponds to medium dirt, medium grease. So in the table you can see medium dirt and medium grease. So here comes 3 by 5. Similarly, say medium dirt and large grease. Medium dirt, large grease, so 2 by 5 comes over here, and the table corresponding. So 3 by 5 is here. Now see, in your previous table, where is this? So this 3 by 5 is nothing but the middle element. So this is the middle element. So medium dirt and medium grease, medium dirt and medium dirt, we have assigned the value medium time for that. So the time is medium for that. So hence you will put this value 3 by 5 in the equation of medium time. So what is medium time? Here these are the equations for the time. So here you can see this is the medium time over here. So here you put the equations. So hence you get 3 by 5 is equal to z minus 10 by 15. So here you can see these are the equations for medium. So z minus 10 by 15. So here will become 3 by 5 is equal to z minus 10 by 15. 3 by 5 is equal to 40 minus z by 15. So these are the two equations. So you get these two equations. Now what you do, you get the value of z. So from here I get z as 19 minutes, from here I get z as 31 minutes. Next you take the average of these values, because I want one value, right? So I take the average of this value, I get 25 minutes. So for this input 60% dirt and 70% grease, I get the value as 25 minutes. Also let's see what we did graphically. Initially we had these graphs. We designed the input descriptors, the output descriptors, we designed the range, and we got this graph. Next we got these equations. These equations are nothing but the line equations. Remember that whenever you put the value that is over here, 60% grease, 70% grease, these values should be all less than 1 and greater than 0, means in the range of 0 to 1. It should be never negative and never greater than 1, because as I explained before, it is nothing but this range. So this value can never go above this or below this. Okay, so next what you do is you get 60% or 70%. So here you can see I have considered 60% over here. So 60% corresponds to this. So here 60% crosses this point and this point over here. So hence you get these two equations and the two corresponding values. I guess that was 4 by 5 and 1 by 5. So here I got 4 by 5 and 1 by 5. Similarly here I consider 70 and 70 cut these two values, and correspondingly I got 3 by 5 and 2 by 5. Next you take the intersection, you get these values. Intersection means minimum. You get these values. After this take the maximum of this value, so that is 3 by 5 over here. That 3 by 5 you see where it is. So this 3 by 5 is medium dirt, medium grease. So accordingly you understand from your table, you have to design this table, that is medium time. Take the medium time equations. These are the medium time equations. Put the value 3 by 5 over here. Understand what we are doing is, from here we go to the y-axis. Now we are in the y-axis and we want the values of the z-axis. Hence we have to put the values over here in the y-axis place. So here will come 3 by 5, 3 by 5, and not here. Please remember this. So there will be 3 by 5, 3 by 5, and you have to find the value of z. So you get two equations, you get two values of z, take the average, and you get your answer. Also consider this sum. This was a very interesting sum that I got, and hence I would like to tell you about this. Design a fuzzy controller for a train of station. The inputs are distance from the station and speed of the train. The output is brake power used. Assume that triangular membership function, 4 descriptors for each variable, 5 to 6 rules, approximation of the defuzzification method. So here what we have is, there is a train, there is a station. So the input is the distance of the train. Say this is the train and say this is the station. So distance of the train from the station, this is one of the input. Second input is the speed of the train, how much fast the train is going, that is the second input. And what is your output? Output is the brake power, how much brake power should I apply so that the train can stop at the station. So that is our sum. So here you identified the input, say that was distance and speed. So distance I am taking 0 to 500 meters, the range, and speed I am taking say 0 to 60 kilometer per hour. This is the speed and this is the distance. So now this is again up to you, the range is up to you, the range is up to you. They have told us to have 4 descriptors, hence we are having very close, close, far, very far. Similarly, very small, small, fast, very fast. This is far, very far, this is fast, very fast. Please don't get confused with that. So this is the speed, and what is the output? Output is brake power. So brake power I am measuring it at 100% scale. So now whatever things that do not have a unit, basically brake power has a unit, but then you can there is no specific unit. Like if I talk about distance, so distance is in meters or centimeters or kilometers, so that you please keep it in meters. Speed is in kilometer per hour or meter per second, then you, but then brake power, or in the previous sum we saw grease, dirt, all these things you can round it off to 100%, how much percent thing you want to put. So next thing, you put the membership function. So this is the membership function that you can see. You can have any values over here, 150, you can have 200, 300, according to you, your decision. So accordingly find the rules of these equation. So you get the different rules of the equation. The main thing that I wanted to tell you in this sum was this table. When you will write all the rules, and then you will get this table, that is the two inputs, and then you have to fill, you have to map, basically the mapping that you have to do. So here you can see, here there can be mistakes that most people do. Here I am taking one input, that is very close, close, far, very far. So here this is the distance, and this is very small, small, far, very fast, very fast. This is the speed, the distance and speed. So here if you see, very close and very small. So please understand this, very close is the distance, that means your train is very close to the station. Consider this is the station, so your train is very close to the station, but then the speed is also very small. So here your train is very close but the speed is very small. So how much I need to apply the brake? So I will have to apply a large amount of brake. Let me explain it like this. Suppose I am very far, the train is very far, say the train is over here, and the speed is very slow, means the train is very far and the speed is very slow. So in this case you can see, you'll have to apply very light brake. This VL is very light, so this is a brake power. So when I'm very far and I'm very slow, at that point of time I need very light brake, so that will automatically brake over here. Hence next case, suppose I'm very close, and then I am very fast, at very fast speed. I'm very close, distance is very close and speed is very fast. So at this point of time I'll have to immediately brake, and very large amount of brake. Hence this should be very heavy. This is very heavy. So hence, so this is very important over here. Then I'm very close and speed is small. If the speed is small, it's okay, but then you will have to have light brake. Say light brake will be good. Then you are close, now you are close and the speed is very small, so light is okay. So very light, accordingly you can manage. So here, so what I wanted to say is, now for very close and very small, applying very light brake is not logical, because you are very close to the station, so you need to apply a little light weight, a little more weight than very light. Similarly over here, you are very far but your speed is also very fast, so accordingly you can have light brake or heavy brake. So this table is basically according to your logic or your intelligence, but then you should understand these small things. Means you cannot have a very large over here or very light over here, because this is something in the middle. You are very close, but then speed is very small. So this was an important thing that I wanted to discuss. So please take all logic in your mind when you are designing this table, and then the rest is the same. You have to put the values, you put the values, you get the what we call the y-axis values, to put the y-axis values in the to the output timeline. So the rest the sum is same. This thing was that I wanted to explain. And yeah, thank you so much for watching my video. Thank you very much, and all the best for your exams.